Hello and welcome to this lecture video. In this video I'm going to talk about the example right here on how to do account analysis. In the prior lecture video I kind of went over what account analysis is at a conceptual level. Now we're going to look at a problem on doing an example problem with account analysis, and then we'll also talk about the Scattergraph approach, and then we'll also talk about HighLow. All right? So let's assume that we make a barcode reader. We're a company that makes a barcode reader, and we have a total cost of $265,000 for making 2,000 units. The first step in account analysis is we would want a breakdown of where does this 265 come from? How do we get to this number? How much of this is labor? How much of this is materials? How much of this is overhead? So let's say that we did that. And we did some background checking. We said that our component cost, which would be our materials, is equal to $130,600. Okay? Let's say that our labor cost is equal to $32,400. Let's say that we have utilities is $7,100. Let's say that we have rent at $22,000. And then finally we have depreciation at a cost of $72,900. The sum of all these is the $265,000, okay? So that's the first thing that we would do, is we'd have to go through here and we would have to say, how did we get to this 265? The next thing that we would do is go through and classify these costs as variable, mixed, or fixed. So when we think about direct materials, we should know that it is a variable cost. So I put a V for variable. Direct labor. This is our assembly line labor who are paid hourly. That's a variable cost. Utilities, we went through in the first lecture video where we said utilities is an example of a mixed cost. Rent and depreciation, we know those are both F for fixed cost. So that would be our breakdown. That's what I'm saying right over here. So that's step one, figuring out where do we get this cost? What are the components of this cost? And then classifying each of those as variable, fixed, or mixed. Okay? So let's say that we did that, and here's kind of like what we have. The other thing that requires some judgment. So we've done this, we did that, our variable, variable, fixed, and then fixed and fixed. Now our utilities, we said, is a mixed cost. And what we would have to do is rely upon prior experience and our professional judgment to say, of the utilities cost, how much of that utilities cost is fixed, how much is variable. So what we're saying right over here, our assumption is that based upon our professional judgment and prior experience, we think that half of that 7,100 is variable. Half of that 7,100 is fixed. And that would be done through professional judgment. Keep in mind, this is all at 2,000 units. And so what we want to do, maybe we want to say, all right, this is our cost breakdown at 2,000 units. What would be our total cost at 2,500 units? Okay, so what we can do is we can use what we understand about variable cost per unit and total fixed costs. Now, one of the things that I want you to think about is this is variable cost per unit. How did we get that? We added up all of our variable costs and we divided by 2,000 units and we got $83.28. Now, here's the question for you to think about. If we make 2,500 units, what happens to this number? Does this stay the same? Does it increase or does it decrease? If you thought about it and you said it stays the same, you were right. Because what do we know about variable cost per unit? They stay the same. Okay, so what we can say is we know that our variable cost per unit, $83.28, stays the same. So as we move from 2,000 to 2,500 units, all we would have to do to figure out total variable costs is to multiply 2,500 units times $83.28 per unit, and that would give us the total variable cost at 2,500 units. Okay, now this is our total fixed costs at 2,000 units. And what I want you to think about for a second is what would be total fixed costs at 2,500 units? It would be the same, because what do we know about total fixed costs? They stay the same. And we are assuming here that we are within the relevant range. We haven't been told otherwise, so we can assume that we are within the relevant range. So our total fixed costs also stay constant at $98,450, okay? We can use that information to help us estimate what total costs would be at 2,500 units. So looking on the next page, we can say our total costs at 2,500 units would be equal to our 2,500 units times our variable cost per unit, which we know stays the same. This is our total variable costs. We know our total fixed costs are $98,450. This was our $98,450, which we had for making 2,000 units. But we also know that total fixed costs stay the same as long as we are within the relevant range. And we know that we are, because we haven't been told otherwise. So therefore, fixed costs stay the same at $98,450 at 2,500 units. Total variable costs plus total fixed costs gives us our total costs. This would be our total costs at 2,500 units. Why is this something we want to know? Well, if we know that we sell each unit for whatever price at $100 or whatever price that we sell it for, right? Maybe let's say $150. We could then take 2,500 times 150, which would be our sales, minus our costs at 2,500 units, then that would give us our profit at 2,500 units. And that's something that we do care about. Okay? What's the problem? Very subjective. Think about how we went through and we said, well, we think half of our utilities costs are fixed. Half of the utilities costs are variable, because remember, utilities is a mixed cost. So what we have to do with that mixed cost is divide it into its variable and fixed components. So we kind of made a guess based on prior experience. We said, well, all right, we think that it's half and half. What if we're wrong? It distorts this number and it distorts this number. So it's subjective. You could have different managers say, well, I don't think it's 50-50. I think it's 60-40 on utilities. Okay. So it's subjective, and that's, it's not perfect. Okay. But it's used a lot because it's easy to do. Okay. All right. So let's talk about another one, which is a scattergraph approach, which would be a visual fit, which we could do. We could plot our total costs at different levels of activity. And what we would do is we'd want to have the line that best fits the data. And when I say the line that best fits the data, it's the line that minimizes these errors. This is an error because the data point is not right on the line. So this would be a poor fit. This would be a good fit, because look, the errors, that's a smaller distance than some of these distances. So this is a better fit. Once we draw that line that best fits the data, we could estimate the slope. And then we could say, we could choose a point on the line, and we could say, all right, this is the total cost right over here. We know the slope. And then at that point, we also know the level of activity right down here. And so we could back into figuring out our fixed costs, all right? So we know our y equals a plus bx. What we could say is, we know this number, and we just estimated the slope by looking at the line. So then what we can do is then we can say our total costs minus our total variable costs, and then that would give us our fixed costs right over there. Now you can imagine that the problem is that this is also very subjective because you're trying to visually figure out the line that best fits the data and then visually try to figure out what would be the slope. So this again would not be an ideal technique. Okay. Let's talk about high-low, which is another way to estimate cost. So what I just talked about right over there with the scatter graph is one other way to estimate cost. We talked about account analysis. We talked about the scatter graph approach. Now let's talk about high-low. So the way the high-low method works is it goes back to some of your high school days with algebra. Remember rise over run? That's basically what we're looking at with in terms of high-low. Okay? So what we're going to do with high-low is we're going to choose the high and the low levels of activity. And then we're going to then look at the associated cost with that high activity and then that low activity. Okay? Then what we're going to do is we're going to then take our difference in total cost divided by our difference in the activity. So if you think back to, I just remember high school algebra, always learning about rise over run. I'm not sure they still teach it that way. That was a long time ago. But assuming that they do, this is all that we're talking about, is calculating the slope. Why do we do that? It gives us our slope, which is our variable cost per unit. And then once we know our variable cost per unit, we can back into figuring out our fixed costs. So we look over here. We're going to look at our change in activity. That's the first thing that we do. We find our high activity and then our low level of activity. That's our high. That's our low. And then we look at our associated costs. And when you do the math, what you get is $5 per unit. Now what we're looking at over here, this is our total mix costs. So what we're going to try to do, the whole point of this is to divide this total mix cost, parse this total mix cost into its fixed and variable components, so then we can estimate it. Because we can't estimate mix cost without first dividing it into variable and fixed components, because we know how variable and fixed costs behave. Once we divide it into those different cost breakdowns of variable and fixed, then we can estimate it. So that's why we're doing this. Okay. All right. So now what we can do is we're going to have to figure out what our fixed costs will be. And so the way that we can do this is we can either choose our total mix cost at either our high or low point minus our variable cost times our activity. So let's go ahead and choose our high level. So our cost at the high level is 5,500. So I'll say FC equals 5,500 minus, and then what's my high level of activity? 500 units times my $5 per unit. Fixed costs therefore equal $3,000. Okay? So I backed into figuring out what my fixed costs will be. Now, what I can do now is I can use that to help me do some cost estimation. Because you can see right over here, I don't have 700 units. But that's something I might want to know. What would be my total mix cost at 700 units? But I can figure it out. How can I figure it out? I can say my 700 times my 5, this equals my total variable costs. And I can say total mixed equals total variable costs plus total fixed. So what am I doing here? Is I'm using what I understand about variable cost and fixed cost behavior. I'm saying I can figure out my total variable cost by multiplying my level of activity times my variable cost per unit, which I know stays the same. And then I know that my fixed costs are $3,000 at 500 units. What will be my total fixed costs at 700 units? 3,000, because total fixed costs stay the same as long as they're within the relevant range. All right, take a second and do this problem, pause the lecture video, and then come back. Hello, thank you. This is what you should have got.